Now, in both of the examples that we just finished looking at, the clone method in the object class was sufficient to properly clone the array list and the array. That won't always be the case. There may be objects that don't get cloned properly by that default clone method that's in the object class, in which case it may be necessary to override the clone method with an appropriate version for a particular object that you wish to be able to clone. The clone method isn't generally public. It's declared as protected in the object class, but that means that classes that derive from the object class do have visibility for the clone method and can override it. Notice the declaration: protective native object clone throws clone not supported exception. Everything that's in there you're familiar with except for one interesting little bit, and that's the part that says native. The term native describes the fact that there is no Java source code for this clone method, but rather it's written directly in bytecode for Java to directly interpret. The reason for that is to make it extremely fast and extremely efficient, because you want a process like cloning to take place as quickly as it possibly can. You don't want the overhead of having to have it written in a higher level language like Java and then converted or compiled. In the next slide, we're going to examine overriding the clone method in a situation where we have a class named house that's going to implement the clonable and comparable interfaces. Well, let's start by looking at the implementation of our house class. So at the top here we have public class house implements clonable, comma, comparable generic argument house. Our house has three private data members: an ID, which is an integer, an area, which is double, and something called when built, which is a java.util.date. There is one constructor which follows in our house class. It takes an ID and an area, and it sets the appropriate data members to those values that were passed as parameters, and that's all very familiar code. You know how to do that. We've talked about it a number of times already. And then it sets when built equal to the current date. We're not going to allow the ID for a house to change, but we will have access to it using a getter that we've provided next in the code. That's about the middle of the slide now. And then second from the bottom of the slide, we have a method to compute the area of the house, which is going to return the area, which is just, we aren't actually going to compute it, but it's stored as a data member. So it's simply a getter for area. And finally, at the bottom of the slide, we're going to provide a getter for the date that it was built. Here we're going to override the clone method that exists in the object class, and we're going to do this in the implementation in a try catch block. We're going to return the result of calling our superclass with the clone method, and that could throw an exception because clone might not be supported. So down below we have a catch that says catch clone not supported exception and returns null if that happens. We're also going to override the compare to method that's defined in the comparable interface, and we're going to do that by deciding what basis we're going to compare houses on, and we could use date created or we could use ID number, but the most sensible thing in the context of houses would be to compare by area. So what we do is we return +1 if the area of this house is greater than the area of the argument house that we're passed. We return -1 if the opposite is true, and if neither of those things is true, then the houses must have the same area, in which case we return a 0.